computer, and now I'm recording. So I guess we can start the class. I'm going to open my PowerPoint and I'm going to put it on the side. I'm just going to use it as a reference for me. And most of the time I'm going to be moving between Eclipse and this Paint software. Let me just make sure that, and I want you to help me here. Let me just open the, yes. I'm going to switch between the Paint and Eclipse. And I want you to let me know if the screen that you're seeing right now is correct. Now, are you guys seeing Eclipse? And you can use the chat to answer this question. So that's a yes. Okay. And let me move back to Paint. And now you guys should be able to see Paint. Okay. Sounds good. So we should have no problems. Let me just make sure that I can see everybody here. I know you guys are not seeing what I am seeing, but it's okay. Okay, let's keep switching again. I just want to make sure, because sometimes, okay, I have no choices but to do this. Just trying to. I just want to let you guys know that I am trying to manage my screens because I have two of them. Okay, so today, as I said, we're going to be talking about arrays. And the concept of arrays is very, very important. And I'm going to go through it, of course, with a lot of details. But before we jump into that, let's just talk about a case or an issue that we are having and we need to address. Now, in reality, programming is all about testing data and processing data. There is a trending topic in computer science these days called data analysis, which is gaining a lot of attention. And the idea here is that by having a lot of data, how can I use that much of data to make decisions? Like, for example, you're trying to invest, you're trying to start a new business. You have a huge database about other businesses, about other investments. You want to use those data to process them so you can come up with a clear decision about should I get involved or I should not get involved. So you can see here that processing data is critical, is important, and you can use it to make really, really important decisions. Now, when it comes to data, let's go back to what we learned so far. We said every time you want to create a you want to store data in your computer system, you simply create a variable. So, for example, integer. Let me just increase the font size here. Integer, for example, x, and x equal 10, for example. So inside your memory, you're reserving space and you're calling that space x, and you're storing the value 10 inside that x. Now, this is okay. This is acceptable for one variable, two variables, three variables, five variables. Now, the question is, what if I have millions of these variables? What if I have, for example, I have a classroom, let's say, and in my classroom, I have 100 students. And I did a test for those 100 students, and each student has a grade. Now, I want to study the grades of those students so I can tell what is the average, what is the max, what is the minimum, what is the standard deviation. Standard deviation simply means how far the best students and the students with the least grade are from each other. Of course, my goal here is that I want to have, for example, if this is my scales from 0 to 100, and 100 is the highest grade and 0 is the lowest grade, what I wish my average is closer to 100 rather than closer to 0. So, for example, let's say it was at 80. That's my average. Now, after that, I wish my standard deviation to be very, very close to this 80. Simply means most of the students, let's say, take plus minus 5 from this 80. That's for me is considered as a good result for my whole class. Of course, having a standard deviation, for example, to be way far, for example, plus minus 25, that's not a good thing, because that simply means a lot of students falls behind here and some students got to the max. Of course, that's okay. But the more I'm far away from the standard deviation from the mean, simply means I have data that's distributed through the whole range. And for me, again, because I'm trying to do analysis for the grades, I believe I want to have all the grades very close to the average. Now, this is not the point of what I'm saying here, but the idea here, let's just focus on this number here, which is 100. The question that I'm going to try to ask here, since I have 100 students, how am I supposed to, and let me just put it there, how am I supposed to store those 100 variables? Now, traditionally, this is what we said from the beginning of the semester. Every time you want to store a value, you create a variable for it. So with that being said, if I move to Eclipse, let's say I have 100 students. So here, look, this is how it's going to look like. Integer stu1, let's say, equal 89. Integer stu2 equal 76. Integer stu3 equal, let's say, 65, and so on. I have to go all the way to integer stu 100 and assign the value 9 to it. Now, even though when it comes to programming, the compiler will not complain about that. Yeah, you want to create 100 variables? You want to create 1,000 variables? You can create 1,000,000 variables. I'm okay with that. I will execute it with no problems. But the question is that efficient? Is that a good way? No, it's not, for many, many reasons. Reason number one, the more variables you have, the harder and more complicated the program will be, because a simple modification, let's just put it that way. Let's imagine I decided that I want to go and increase every one of those students with 2 points. I just thought about it. I looked at it. I was like, if I just add 2 points to the students that I have in this classroom, 25% of the students will pass the class. I did that based on an analysis. And then, okay, so what do I have to do in that case? Well, here's what you're gonna have to do. You're gonna have to come here and say, student 1 plus equal 2. Student 2 plus equal 2. And so on. So you can see here, based on this example, that having a single variable for every single grade will simply require me to create 100 variables. Now, let's imagine we're talking about the population of a city, and we want to have a record for every single citizen in that city. And let's say we have a big city where there's like 1 million of the people who live in that city. So that simply means you have to create a million objects. So based on this example, I want to tell you, creating variables to store your value will be okay if you know that you need 1, 2, 3, 4, 5. But the moment you get to a point where I need to have a lot of variables to store the values, at that point, we have to switch our thinking to move from traditional variables to what we call data structures. And data structures is a way that we can organize information and data. So instead of having all my variables created, and that simply means multiple variables created, I can simply create one element, and that element will hold all the data that I want to. An array is the basic definition of a data structure. array is the core of multiple data structures that are designed from it. In this class, we're going to focus on arrays, and we may mention another type of data structures called lists, or in Java, they call it array lists, and that will be something to talk about at the end. But arrays is the core of this chapter, and array, again, will provide us with a lot of services that will make our job easier. Job number one, instead of me going through hundreds of variables to create, I can simply replace all these 100 variables with one declaration, and I will show you that in a sec. That'll be number one. Number two, whenever I want to modify these variables, and instead of having a single link that's going to go by one, string number one, string number two, string number three, string number four, all the way to string 100, I can just use a for loop and get the job done. And this technique that I'm showing you right now, that I'm highlighting, there's no way you can use a for loop here. But with arrays, you can use for loops. So you are simply saving yourself from redundancy in a lot of cases. So instead of me creating 100 variables, I'll create one array. Now, let's go to the definition of array, and then I'm going to show you how can we use and utilize arrays. Array is a simple, I don't want to call it a variable because it's not a variable to be specific, but I want you to think about it. A single variable like this one here that I'm highlighting can only store one value. Think about an array as a variable that can store multiple arrays. Multiple values. So a single variable can store only one value. Array can store multiple values. And that's how we can save a lot of space from redundancy, like I'm repeating this line multiple times. I can, instead of doing this, I can again simply just create one array and then with one declaration, and that will be it. So let me just take this away. Let me take this away, and let me take this away, and let me take this away. And that's what array. So array, again, it's a data structure. And it will have a data type. This is very, very important. Like when you create an array, you must tell me what type of array it is. Is it an integer? Is it a string? Is it a character? Is it a double? That has to be specified. Every single array will contain elements. Okay. All these elements in that array will share the same data type. So you cannot mix and match. Like there is no array that contains strings and doubles and integers. Despite, unlike Python, which is not array again, but you can create a data structures where you have multiple data types. Most important thing about arrays is how do I have access to the items of the array? And we're simply going to use something called indexes. And I'm going to explain what are indexes in a sec. So before I continue, let me take all this away. And let me start with creating an array. To create an array in Java, you have to start with telling me what is the data type. And in this case, I'm going to go with an integer. You follow the integer with the square brackets, opening one and closing one. And then after that, you tell me what is the name of the array. I will just call it students grades. And I'll put semicolon. So this is me creating an array. Usually, whenever you create an array, this is acceptable. I can go and once I created the array, the next step is for me to assign values to decide what will be the size of the array. And in this case, I created an array, but there is no size that I added here. So what I can do, I could come here and type new. Look at this, integer, and you open a square bracket and you close it, and you come here and you tell me how many student grades you want to create. I want to create, for example, 10 or 100 or whatever the number you have. And here we go. This is how we create arrays. Now, there's another way to do that, which I am going to explain in a sec. Well, let me just jump to it. I'm going to give you another example this time. Integer. I'm going to call it test array. And I'm going to say equal Now I'm going to open the curly brace and close the curly brace, and I'm going to put 1, 2, 3, 4, 5, 6, 7, 8, 9, for example. Those are values that I just chose. So this is an array, and this is another array. Now, what's the difference between those two arrays? This array, let me just put 0 here as well. This array, I decided to create an array. I'm calling it student grades with a size of 10 elements. So I'm going to explain that, how is that going to look inside the memory in a sec. And here I decided to create another array called test array. But instead of going with this technique, I decided to open a curly brace and close a curly brace, and I listed the items inside that array. So in this case here, the values of the items student grades is not specified. I just reserved 10 spaces. What are these values? They're going to be simply 0. Automatically, Java will assign 0 to them. Here, no, I decided to create an array. What is the size of the array? Well, right now I don't know, but if I count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I have 10 values, 10 variables, or 10 values. The first value will be 1. The second value will be 2 and 3 and 4 and 5 and 6 and 7 and 8 and 9 and 10. What is the value of this array? They're all zeros. So those are the two different techniques that we can use to create arrays. Now, just to verify what I just did, if I go here inside system.out.println, and if I just come here and type students grade, open a curly brace and close it, and I'm going to do the same thing for the second one, Control C, Control V. This time we'll call this one test array. Now, before I do anything, let me take the square brackets away. He's complaining about this. I think I just misspelled something. Yes, I did. Copy that and put it here. Now it's gone. So let's look here. I decided print student grade and print test array. If I run this program, I want you to look at the bottom here. Look at this. Those values, again, we talked about them before, but it's 626B, 2D, A4. Sorry, for 8. The other one is 5E265 BA4. Now, every time you see an E, an A, a B, a D, think about that as a hexadecimal numbering system. So when you try to print the array itself, it's simply going to show you an address. Now, the question is, what is that address? And once I'm done with that address, I'm going to go back and come back here. So let me move to the paint. And before I move to the paint, let me just copy those two lines. No, cancel. Copy. And let's just put them here. Those are my two lines. So now the question is, what are student grade and what is test array? Now, let's just go back to how we understand variables. Inside your memory, whenever you create a variable, for example, like integer x equal 100, we simply said the operating system will look for a space inside the memory, is going to call it x, and it's going to store the value of 100. And that's, again, for this definition. Now, let's just take that out, and let me show you how does it work for arrays. Since, for example, this one, since it's an array, and since the size is 10, the computer operating system will reserve a space inside the memory to store 10 values. I'm going to assume those are my 10 values. In reality, it's much more than that. Just put a space here. So this here, the space here, starting from this point all the way to this point, is reserved to store this array. Now, this array by itself, it will hold. Now, let's look at this one specifically. this memory location that I'm going to be pointing at, the array name or identifier will simply hold the address of the first memory location. So if this memory location has an address of, let's say, A3B, then A3B is simply going to be stored in this. Same thing goes for the test array. There will be a space inside the memory where it's going to be reserved. There will be, again, since I decided to go with 10 values here, by the way, you can go up, you can go down. It's up to you. There will be 10 spaces. And again, just like we did before, this is the first memory location. Imagine the memory location address is 113A. So that simply means this is going to be stored here. So when I went to Eclipse and I told him to show me what is a student grades and what is test array, he simply showed me those memory locations. Now, again, I am not here for the memory locations. I'm here for the variables. So here's what's going to happen. For this test array, the first memory location will hold the value of 1, 2, 3, 4, 5. And you know what? Let me just change this a little bit, okay? I don't like the numbers because the numbers could be misleading. Let me just go to my code again, and I'm just going to put random values. For example, 11, I'll put here 6, I'll put here 2, I'll put here 14, I'll put here 52, I'll put here 36, 17, 91, 81, 99, and let's say 30, 32. So those are my values. Let me copy them. Just imagine those are my values. I'm going to go back here to the paint. I am going to come back in a sec. Just stay with me. That's still okay. That's still acceptable. Okay. Sorry for that. I'm back. So here we go. This is my array, the new one that I just decided to use. And let's go ahead and assign values. Inside the memory, here's what's going to happen. This one will hold the value of 11. This one will hold the value of 6. This one will hold the value of 2. This will hold the value of 14. This will hold the value of 52, 36. And what do we have? 17, and then 81, and then 99. And I think I missed 1, 2, 3, 4, 5, 6, 7, 8, 9. There's still one variable, which is 320. So this here is the space. So inside the memory, again, inside the memory, what do we have? We have 10 spaces reserved for the array, test array. The test array by itself, it's holding the address of the first memory location, and the values are stored inside that array. Now, for the first one, since I didn't specify any values, I just decided reserve 10 spaces. Java will automatically assign default values. And in this case, those values are simply going to be zeros. So let me make sure that I get 10 of them. 1, 2, 3, 4, 5, 6, 7, 8, 9, and there's a 10th one. And that's how arrays looks like. And this is what the memory looks like for arrays. Now, the question that I'm going to ask is, how do I have access to those arrays? Like, for example, if I want to have access to this value, or if I want to have access to this value or this value, how do I have access to them? How do I see what they are? How do I change them if I want to change? And by the way, I want you to put object-oriented programming on the side right now. We covered that topic. It's gone. We're moving to a different subject. So how do I have access to every one of those items? And to do that, we have a concept called index. And I'm going to explain the index for you in a sec. Now, index represents the location of each value inside the array. So each one of those values has a location inside the array. And that location is an integer. It has to be an integer. And we start, the first value we have in the array will have an index of 0. So 11 has an index of 0, 6 has an index of 1, 2 has an index of 2, 14 has an index of 3, 52 has an index of 4, 36 has an index of 5, 17 has an index of 6, 81 has an index of 7, 99 has an index of 8, 320 has an index of 9. This is extremely important because I've seen a lot of students make a mistake when it comes to their arrays. You always start counting, or your indexes or your locations of these variables simply start from 0, not 1. Now, another fact that you should know, that the last index in any array is simply the size minus 1. So since I have 10 values here, the last index is going to be 10 minus 1. Same thing, of course, applies here. Now, the question is, how do I have access to them? Now that I know I got the name of the array, I have index represents their location. The question is, how do I have access to them? And the answer will be very simple and very easy. All you have to do, once you created the array, you go and you just write the name of the array and you open a curly square brackets. And then in this area here, you decide, for example, I'm going to go with 3, 4, and this one I'm going to go with 5. Now look what's going to happen. Remember here, when I just asked the computer, my software, my program to just print student grades, it showed me an address. Now that I'm using those subscriptions or indexes, if I run it, I'll simply get values. The first one is 0 because we said all the values here are assigned to 0. The second one, 5, is 36. Now, if you count, this is 0, this is 1, this is 2, this is 3, this is 4, and this is 5. And by this, I mean index. So at index 5, the value was 36. And this is, again, how we create an array, how we assign values to array initially, and this is how we have access to them. Of course, look what I can do. I can come here and say students grade of 4, and I will assign the value of 78 to it. So I was able to have access to it and change it from 0 to 78. And this 5, if I want to do the same thing, test array, and then I will just say 5, and I will set it to minus 90, for example. So what I did simply, it was 36, I changed it to 90. And here it is. So let me run it again. And you can see here the values have changed. I can tell you this is like mostly everything about arrays. Now we just have to learn, how do we use arrays in a more efficient way? Okay, and how our arrays are created. Now let me just show you a little bit of details here. Let's look at this array and this array. The name that you use for the array, the identifier, again, follows the same rules that we use with variables. Okay. And also, for example, test array and student grades array, the name of the array gives me a better idea about the purpose of creating this array comparing to the test array. That would be something to put under consideration. The size of the array, you need to know the size of the array once it's created. That's very, very important. And once the array is created, you should know that you cannot change the size. So if you decide to go with 10, you're going to stick with 10. If you decide to go with 20, you're going to stick with 20. There's no way you can change the array size. Now, what if, and I'm going to show you that, what if I put, show me the index of 14 or show me the index of 15? Now, this is going to lead to a problem. Why is that? Because I reserved 10 spaces, and here I reserved 10 spaces as well. And now yet you're trying to have access to an element at an index 14, which doesn't exist. Because the last index is 9 and the last index here is 9. After that, it's not your business. It's a memory location that belongs to a different software. So if I run it, I will be shot by an error message. It's telling you, look at this error. array index out of bounds. So it simply means you passed your limits. So this is, again, one thing you have to pay attention to when you create arrays. Now, let me just go back here. And let's imagine for this array that I have, you know what, let me just put it back. What is going on here? Let me take this away. Let's imagine I want to change the values from the default value to an actual values that is supposed to be assigned to the grade students. Now, here's what I can do. And let me just do that right now. So if I create a scanner, inputs or in equal new scanner by system dot in, without the double quotations, of course. And we have to import scanner as we usually do. And I'm going to go and type in dot close. Okay, now that I have in dot close and I got scanner here, I want to assign values to each one of those values. So look what I can do. I can come here and see of I equal in dot next integer. Of course, we said this is not the best way. Oh, sorry, not I, 0. This is not the best way to do it. We have to put a message. So I'm going to go here, system dot out dot print, and I'll say enter a student grade. And look what I'm going to do. That's for the first students. Since I have 10 students, I'm going to have to repeat this for 10 times. So the student of 0, of 1, of 2, of 3, of 4, of 5, 6, of 7, of 8, of 9. So let's do that. 7, 8, and 9. So this is how I enter those values. Now, this is, again, from a look at it, you should know that this is a redundancy. I'm repeating the same thing over and over, and I'm only changing one thing. This is considered as redundancy. This is a bad practice for programming. Now, let me show you, what if I want to show the results after that? Well, I can do that same here. I can copy this, put it here. I'm just going to put print line, and I'll just say, student's grade is, and I'll come here and just put, where's the name of the student? Just come here and copy this, put it here, and start with 0. Now remember here, I need to do that for all the students. So I'm going to copy this for 10 times. So 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. And 9. Okay, so let's run it and see what's going to happen. And let me comment on this section here. I really don't want this to be involved in anything. So if I run it, it's simply going to be asking me for the student grade. I'll go for 12, 23, 44, 55, 66, 64, 12, 32, 44, 33, and I'm done. And then after that, I got them all printed here on the screen. Okay. So this is how we have access to those items. But as I said before, is this the best way to do it? Now, here's what I want you to do. And I want you to pay attention to this because this is extremely important. If you look at those two lines together and you compare it with this line and you compare it with this line, what is the only difference that's going on between all these lines? The fact that I have 0 here, and then I have 1 here, and then I have 2 here, then I have 3 here, gonna have 4 here, and 5 here, and 6 here, and 7 here, and 8 here, and 9 here. So what I'm saying here, this is repeated 10 times with only one change is applied to whatever the index is. Now, if we take that and put it under consideration, here's what I can do. I can create a for loop that goes for 10 times. So integer I equals 0. I is less than 10, and then I plus plus. And in this area here, what I'm going to do, I'm just going to come here, take that part, and I'm going to push this and push this. Now let's look at this for loop. What do I have? He's asking me to enter the student grade, and then he's asking me to enter grades to the first student, which is index 0. What I need to do, if I just replace this number with I know for sure I will go from 0 to 1 to 2 to 3 to 4 to 5 to 6 to 7 to 8 to 9. Okay, this is a fact that I know that my index value I will simply change to all these values that you see here. That's the value of I in this loop. It goes start with 0, and then it's going to be increased by 1. So it's going to move to 1, to 2, to 3. So with every iteration, look at this term, the new one. Iteration simply means a loop. Every time you finish an iteration, every time you finish a loop, the value I is going to be increased by 1. So I here is going to be changed by 1, and then you're going to start increasing. So there is no need for me to repeat all this. All I need is a simple for loop to get the job done. Now, just to make it look a little bit better, enter the student, or let me just put it this way, student number, and I'll just put a space here, plus plus, enter student number I plus 1. Great. Now you may ask, what am I doing here? I just want it to be look a little bit better. Now, as I told you, arrays, they start counting from 0. But here, when I count you guys in the classroom, I don't start counting from 0. I start counting from 1. So I'm just adding 1 to the I. So it would show me student number 1, student number 2, student number 3, and so on until I get to 10 students. But I'm not changing I here. I still index with 0, 1, all the way to 9. So let me just run this. And look at it. Enter student number 1 grade, 98. Student number 2 grade, or 3, or whatever. And I got all the students now. Look at this, 1, 2, 3, 4 lines of code instead of having 20 lines of code. Now, of course, the same concept that I did here could be applied for the output as well. So let me just copy this, and I'm going to put it here, and I'm going to take all this away, and I want to show the student grade. So let me just cut this from here and put it here, and I'll say student number 1. Let's put plus plus I plus 1. Grade is, and here just put I instead of the 0, and now I can guarantee you it will work perfectly fine. Let me take this away. Let me run it. And again, he's telling me 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. And you can see here, I got now all my data now is stored in a single identifier that I can have access to all the values using those indexes. Now this one here, I can make it look a little bit easier. Instead of me going through 10 lines of entering variables, here's what I can do. And I'm going to apply that to this array here. let's just imagine this array, instead of going with the predefined, I'll just go new integer. And I'll put 10 again here. Okay, for test array. Look what I'm going to do. I'm going to copy this. I'm going to go down, and I want to show you what's going to happen. I can do it in a different way. And instead of doing this line, I'm going to take it out and I'm going to put it here. And I will say enter. Let me take this out. 10 values for the array test array. Okay, and all I have to do is to do it this way. So my for loop and my array. Look what's going to happen when I run this program. Of course, I have to go with this one again. And look what's going to happen here. At the bottom, the very bottom here, I hope you guys can see that. He's asking me to enter 10 values. Here's what I'm going to do. 34. That's it. I enter 10 values. And here they are. Let me try to show them on the screen. So I'm going to create another for loop. Let's just copy this one here. I'm going to go to the bottom. And instead of showing the, let me just go ahead and wait a minute. Did I messed it up. I was supposed to, where is it? I was supposed to change this one to the test array. So let's just go ahead and do that. Control C, Control V. And I'll do the same thing here. And I'll just say values are. And look what I'm going to do. I'm just going to make it a little bit different. Instead of print, I'm going to go print line. I'm just going to go with print. And I'm going to put a plus. And here I'm going to put a print line. So it's just going to go to the next line. So let me just go back here, print line with nothing, and semicolon. So let's go back and run it again. I'm going to comment this section here, so I don't worry about the student grades. I'm all here for the array test. If I run it now, it's simply asking me to enter 10 values. Look what I can do. Instead of enter, I can put space. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And if I press enter, it's showing me enter value. Oh, I didn't have to do this. I'm going to change this. One sec. Let me just copy this. Control C. I'm going to put it at the top. Semicolon. Put a question in that. And in this case here, I'm just going to start with putting the value followed by a comma and a space. So the values are going to be, so this is entered values are, and it's just going to be printed on screen. So if I run it again, and I'll go 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And he's telling me entered value are 1, 2, 3, 4, 5, 6, 8, 9, 10. How do I'm doing that? Again, just me playing with those print statements. Here, I decided to show the one print statements and enter the values one after other. Now, here's what you need to understand. He's asking for 10 values. So if you enter 10 values separated with a space or separated with the enter, they're all going to be accepted for this for loop. If you enter more than that, you may have a problem. So you have to be careful with that part. Now, for the second part, when I'm showing the values, I decided to go with one message, entered values, and I followed that with a for loop that's going to go from all the values and show them on the screen. Now, there's one thing that I don't like about this comma that you see here after the 10. I wish if that was a dot instead of a comma. So here's what I can do. I can come here and say, if I equal 9, simply means we're talking about the last value. I'm going to come here and do something else, So let me copy that and put it at the top. and I'm going to put dot with no space. So what am I seeing here? I just want to replace this comma with a dot because this is the last value. So it makes more sense to have a comma instead of a dot. So what am I doing here? I said, if I equal 9, what is that telling me? Simply tell me I got to the last value. I want you to print the last value, and I want you to print the dot after that. If it's not the last value, print it as it is with a comma and a space. Now, if I run it, it will work. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And you can see here that I got a dot in a space instead of a comma here. And this should show you how good for loops and arrays are. They are the best buddies in programming language. They work perfectly good together. Now, before I continue, is there any questions? No questions? Okay. So let me take array initialization, final. You can decide if the array is going to be final. Okay. I'm just looking at the for loop. Okay. Now, one part, let me just talk about it right now before I continue, before I forget, which is, what if you have an array, but you don't know how many items are there? For example, you see this 10 that you see here? 10 here is a magic number. What if I don't want to use 10? I want to actually use the length of the variable. Now, me looking at the number here, I can tell that the size is 10. But the question is there any way we can have a program or a function or a method that would tell me how many items do I have? And the answer for that will be yes, we do. So let's look, for example, at the student grade array. If I come here and type an integer, I'll call it size. And since we're going to have two sizes, let's just call it students size. Look what I'm going to type. I'm going to type the name of the array, Control C, put it here, dot length. This would tell me how many students I have in that array. Now, of course, now instead of me using 10, I simply can come here and put student size, and the same thing here for this one. Now imagine this one wasn't 10 students. Let's imagine it was 6 students. I can do the same thing. I will come here and say integer test size equal test array dot length. And that will tell me how many test items do I have. And now instead of using, where did I put that? This is supposed to be done here. So instead of going with 10, I'm going to go with test size. And I will do the same thing. This is number of students. Here's another one. Instead of that, test size. Now, I do have a question, and I want you to think about it, and I can guarantee you that I'm going to put this in the final, and I'm not going to answer it. What is better? Okay, I want you to pay attention to this question. What is better? To create a variable and store the student size in it and use it here, or cut this, or copy it, and put it here instead? You'll get the same results if you just replace the student size here with actually calling the function length to calculate the length. So the question is, which one of them is more efficient? To create a variable and use the variable here, or to call the function in the loop directly? Think about it and let me know. And this is how we do have access. Now, let's go ahead and have a simple application. And I'm going to apply this application to the students class that I have created. Okay, my job is that I want to know who the student got the largest or the most grade, the highest grade, and who student got the lowest grade. What is the average grade for my class. Okay, now this is one of the basic applications for data structures. And whenever you have a collection of data, you want to know what is the greatest value, what is the smallest value, and what is the average value. And I can add to that the standard deviation, but it's a little bit more calculations, so I'm going to skip that part. So the question is, how do we do that? Okay, the idea here is very simple. Since I'm trying to calculate 3 different values again, actually there are 4, because for you to be able to calculate the average, you need to have the sum. So here's what I'm going to do. I'm going to create a new integer. I'm going to call it the highest. And then another integer, we'll call it lowest. And then another integer, we're going to call the sum. And I'll set the sum to 0. And I'll set the highest to 0. And I'll set the lowest to 100. You may ask, what is the reason for that? The reason for that, as I'm going to be searching, and by the way, searching is one of the fundamental operations that we apply to arrays. As we search in an array, we always search in arrays. So since I'm searching for the highest value, I'm just going to assume that the highest value is 0. And if I'm going to be searching for the lowest value, I'm going to assume the lowest value is 100. And then I will start with a summation equals 0. So what do I do here? Again, just like how we did with this for loop, I'm going to copy this and go down. Open a curly brace and close it. Now, my job in this loop is to figure out and find out what is the summation of all the values, what is the highest grade, and what is the lowest grade. To do so, I have to check each one of those values. First of all, before I do any check, I have to come here and say sum plus equal, what's the name of the, here it is, student grades of I. So this is my first operation. What am I doing here? I'm accumulating those grades and I'm adding it to sum. So first of all, sum equals 0. So after this statement is executed, I'm going to get sum to equal the grade of the first student. And then second student is going to be added to the first student. And now I got sum to equal the first and the second student. And then after that, the third student grade is going to be added. The fourth student is going to be added and so on. So this is how I do the summation. Now, the second one, which is the highest and the lowest, what am I going to do here? I'm just going to have to come here and say if the student grade at I, very, very important, was higher or greater than highest, so what is that telling me? It's simply telling me that I have a higher grade now. So again, I take the grade of the first student and I compare it to the highest, which equals 0 at that time. If that student has a grade higher than 0, I simply have to update highest to equal whatever that student grade is. So now my highest grade is simply whatever that. Just to put it in a form of numbers, imagine the first student has a value of 12. And imagine the third student has a value of 3. And imagine the fourth student has a 55. And the fourth one has 1. And then 25. And so on. Okay. So the first line here is simply going to be add 12 to the 0. So I get 12. Now, when I get to this point, I'm checking the value of the first student, which is 12. And I'm comparing to the highest, which is 0. Since 12 is greater than 0, then the highest is going to be updated to be 12. So the new value of highest is simply 12. At the same time, you don't need to have an else in this case. You go and create another if statement, and you do this. You would say if same student, there is a possibility for the same students to have the highest and the greatest and the lowest grade, by the way, was less than lowest. I simply have to change the lowest to that. Now, some algorithms, they simply ask you to assign the highest and the lowest to the first students and then go with the process. But this is just again, I'll just go with this technique. So let's look here what's going to happen. Again, 12 in this case is actually less than 100. So the highest will be 12 and the lowest will be 12 as well at this point. Now let's move on to the next value, which is 3. Now for 3, let's look here. Immediately, a sum is going to equal whatever the previous value of sum, which is 12, plus 3. So this is going to be 15. And at this point, we got 3. Is 3 greater than the highest? Now, remember, highest was 12 previously, and now I'm compared with 3, which is going to be false. So highest is still 12. Now, let's look here. The lowest. Now, lowest previously was 12. And now we're moving to the second value, which is 3. And now I'm compared. Is 3 less than the lowest? Yes, it is. 3 is less than 12. So simply, lowest is going to be 3 at this point. And I got the lowest. Now I move to the third value, which is 55. Now remember, highest is 12, lowest is 3, and the new value is 55, which is going to be simply added to the sum. And previously sum was 15 plus 55. I think that's 70. So we got sum to equal 70, which is the summation of these 3 values. Now after that, we're going to compare the students 55. Now the highest is still 12, and I got 50 now. 50 is greater than 12. So the highest is going to equal 55, sorry. Now I'm going to move to the second student, which is, I'm moving to the second if statement. And now I'm comparing 55 with the lowest, which was 3. And since 55 is not less than 3, so no change is going to be applied here. So this is going to be the highest, and this one's still the lowest. I move on to the third value and the fourth value, and I keep going that way. I keep going that way until I'm done. Let's continue. Now, since I have the sum, I need to find out what will be the average. So I'm going to have to come here and create a double. And I will call it average. And I have to come down here because average simply equals sum divided by the student size. Now, this is going to be a problem because student size is an integer and the sum is an integer. So I simply need to cast one of them. Again, to simplify it for myself, all I'm going to do is that I'm going to multiply sum by 1.0. That's another way to cast your variable. Sum is going to be multiplied by 1.0 to make it a double, and then here. After that, all I have to do is show it on the screen. So I can go ahead and create a print line. Let me copy this. And I'm going to go down here and show you, for example, let's just start with this. Highest. And I'll just put here, highest, Control C. Let me copy this, Control C, go down, lowest. And then lowest. And finally, we have average, and then AVE. Now let's give this a try. Now, of course, I'm going to have to enter all these grades again. So 87, 54, 91, 97, 12, 53. I don't want to have repeated values. I'll go with 7 and then 54. Did I have 54? I have 54. Let's create 34 and then 77, and then 88. So those are my 10 values. Now he showed me that. Now he's moving to the second array. 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. And here it is. So he's telling me the highest grade is 97. And if you look at those grades, 97 is the greatest value. The lowest grade is 7, which is the lowest grade. And the average is simply 60. This is, again, a very, very basic operation. I'm going to continue with the same array. And let's say I want to know in the student grades, if there is a student that got a grade, how many, oh, let me just put it this way. For this list of students, I want to know how many students passed. in this list of students that I have. How many of them passed? Let me just take out the one with the array size. So it's just going to be all about the students. And again, my point here, after I did the calculation, I want to know, again, this is, again, very, very important, because this is how, like everything we've been talking about so far, it's not really programming. This is where we get into the real deal. As you can see here, I have a class that have 10 students. Those are their grades. I'm trying to find who get the highest grade, who got the lowest grade, what was the average. And now I want to know how many students did pass in my class and how many students didn't pass in my class. Let's just put it that way. Well, I need to create a new encounter. I will say passed students, set that to 0. And I can create another integer. I will call failed. Okay. I don't have to create a variable. I'm just going to use the math directly. And look what I'm going to do. I'm going to create a for loop, just like the one that I created here. Curly brace and close it. Now, all I have to do is to check if the student, I'm going to go one by one. If he got a grade greater or equal 60, because that's, for example, is the passing grade in the class. If that's the case, just increase the number of past students by 1. So I'm going to come here, say plus plus. This is how many students passed. Now, after that, all I can come here and print it on screen. And I'll just do this. I'll just come here and say, and student past students. So it's going to show me a number, of course, plus space 34, 45. It depends on how many students passed the course, and did not. And for the did not part, all I'm going to do here is to take the size of the student, how many students do I have, and subtract it from the number of students who passed. And that should be enough. So let's go ahead and give this a try again. Now I'll have to go and enter the grades again. I'm going to go with, again, 67, 98, 55, 33, 11, 67, 71, 91, 81, and then 12. So those are the names of the students. The one with the highest grade is 89. The one with the lowest grade is 11. 60.6 is the average. 6 students passed and 4 didn't. So let's look at those. Did we have 6? 1, 2, 3, 4, 5, 6, and 4 didn't. So you can see here, I hope you can see this, like this is again what programming is all about. It's about processing data to bring your attention to what's going on in a classroom, for example. I can look at this, even though 6 passed and 4 didn't, is considered not good enough. The average is considered not good enough. The highest, look at the difference between the highest and the lowest. All this information that I'm getting from this simple analysis for this array could bring my attention to something that might going wrong in my class. And that's what programming is all about in the first place. I know we create video games, we do a lot of other things, but for businesses, this is what it is. Okay, so this here is a lot of details about what we need to know about programming. I'm not done, by the way. Let me just continue. I'm just following the PowerPoint. Determine the largest element. Inside the book, by the way, inside the PowerPoint, all of this explanation is demonstrated with some animation. I hope that it could be helpful. Index out of bound, I covered that. Declaring an array and the formula parameters, I did that. Okay. What I'm going to do, I'm going to give you guys a break for, I would say, 10 minutes. So at 11:50, I will continue. So let me just go. Let me just go. I'm going to stop sharing. So let me stop this. And I'm going to pause the record. No. Stop sharing. Okay. And where's the record? Pause record. Okay, so the break is over and we can continue. I started recording back again. Let me share my screen again. And for the rest of the class, I'm just going to go through some questions that you need to be thinking about, and you need to ask yourself those questions because they're technical and they're important. And let me just start by sharing my screen again. Can you guys see my screen? Okay, so that's a yes. No, you can't see it. Okay. How about now? Let me just see the chat. Okay, now you can see my screen. I'm going to be asking a question, of course. Multiple questions, actually, not only a single question. I do have multiple questions to ask. And we're going to go through them. Now, the first question I'm going to ask, how do I, whenever I want to use the assignment operator or whenever I want to compare between two arrays, how is that possible? For example, again, we're going to be asking about this assignment operator and this double assignment operator. So I have two arrays and I want to assign one to the other, or I want to compare one with another. Now, this is, again, a very, very important concept because arrays are going to be treated a little bit differently comparing to variables. So let's go back again. I'm going to create two arrays for this one. Integer. Let's go this one, array 1 equal, and I'm going to put, let's say 1, 2, 3, 4, 5, 6 values in it. I'm going to create another integer array. I'm going to call it AR2. And I'm going to keep AR2. Let's set AR2 to, let's say 9, 8, 3, 7, whatever. Let me just make sure here. You guys still can see my screen because I just got a notification about that from Zoom. So I'm guessing you guys can see my screen. Come on, I need the feedback before I continue. Okay, that's a yes. Thank you. So I got those two arrays. Now, the question that I'm asking here, when I type ARR2 equal ARR1, what is the effect of this line? Okay, AR2 equal AR1. To demonstrate that, I have to go back to Paint to explain that concept. And I want you to pay attention here. Imagine this array here is ARR1. And imagine this array here is ARR2. If I come here and say ARR2 equal ARR1, what am I doing here? The idea here is very simple. Let's go back to ARR1. ARR1, we said it holds the value of the first address. So by assigning AR1 to AR2, I am simply, now let's look here. This is AR2, the address of the first one, which is, we said 113A. By typing AR2 equal AR1, I'm taking the address of the first array and I'm assigning it to the second array. So based on that, what's going to happen? Simply, this means that AR1 is pointing here, and also AR2 are pointing here as well. So I have two arrays referencing the same spot inside the memory. You may ask the question, how about this? This is going to be cleaned by the garbage collector. So the bottom line, when you use the assignment operation between two arrays, you are simply making the second array that you have in the assignment operator from this expression to be referencing the same array. So there will be the same spot inside the memory, and you can reference that array using this one or using this one. Now you may ask the question, what if I want to keep both spaces separately, but they're just going to have to share the same value? If that's the case, then you have only one choice, and that choice to go and copy each element from one array to each element from the second array. So how is that possible? Let me show you. For example, we said those two arrays, if I simply use the assignment operator, I'm making this array 2 to reference the same array that array 1 referencing. So simply both of them are referencing this one. Now, what if I want to do, what if I want AR2 to simply contain the same value? So inside the memory, I'll have two arrays. They just share the same values. If that's the case, you need to have a for loop. Now, remember, in this for loop, by the way, sizes are going to be an issue here. So they need to share the same size. So for you to be able to do that, otherwise we will have some issues. So integer I equals 0, I is less than 5, I plus plus. Now me typing I is less than 5 is not a good idea, but I'll just go with it. So all I have to do here is to come here and say AR2 of I equal AR1 of I. What am I doing here? I'm taking each value from AR1 and I'm assigning it to AR2. So after the first iteration, 9 is going to become 1. After the second iteration, 8 is going to be 2. Third iteration, 3. This is going to be 4. This is going to be 5. No change. And this is going to be 6 after executing this line. So let me just copy this. And I'm going to put it here in a form of a comment. And I'll just say it's going to equal 1, 2, 3, and 4, and 5, and 6. So this is, again, a topic you have to pay attention. You're not allowed to use assignment operator when you want to assign an array to an array, because that simply means both arrays are going to reference the same spot in the memory. If you want to duplicate this array for any reason, then you're going to have to go with a for loop and get that job done. What else do we need to worry about? That will be number 1. How do I compare between two arrays? Now, again, I can come here and say if AR1 double equal AR2, then something's going to happen, else something else is going to happen. Now here, when I use double equal with arrays, I'm asking this question. I'm asking if AR1 and AR2 are referencing the same spot inside the memory. I'm asking this question, are those two arrays referencing the same space inside the memory? And if the answer is yes, then it's going to be true. If the answer is no, then it's going to be false. So I have to, again, let's go ahead and show you how is that possible. I'm going to take this away and just keep it that way. So I'm going to come here and say system.out.print line, and I'll just say true. And I'll say false. So I'm asking here if both arrays are referencing the same spot inside the memory. So we'll just go ahead and put false. Now, of course, for me, I'm just going to cut this part from here all the way to here so I can get rid of any execution happening here. So and let's see. So I got array 1 and array 2, and then I decided to assign array 1 to array 2. So both of them are going to be referencing the same spot inside the memory. Uh-oh. What was he complaining about? He doesn't recognize ARR2. And the reason? Why is that? That's weird. Unresolved compilation problem. It cannot be resolved. Oh, here it is. Look at that. Has nothing to do with the arrays. So here it is. It's true. So he's not complaining about it. Basically, those two are referencing the same because I've used. Now, if I take this one away and take this one away, take this one away and take this one away. Now, we said after you perform this operation, whatever the value of AR1 is going to be assigned to AR2. Now, the question is, are they both going to be referencing the same spot inside the memory? Let's give this a try. And it's false. And I can guarantee you, if you print array 1 and you print array 2, you will get the exact same values. But because this is a space inside the memory and this is another space inside the memory, this is a deep copy again. So you will have two spaces inside the memory. So this assignment operator is simply checking if both of them are actually referencing the same spot inside the memory. Now the question is, what if I want to know if the values are identical in both arrays? If that's the case, you have no choices but to compare them one by one, just like how we did it here. Now, here's what I'm going to do. I'm going to create a method for that, okay? So I'm going to come here and create if, look at this, AR1, before I do that, same array. That's the name of the method. I'm going to pass AR1, R2. Close that. Now, of course, he's complaining about something. Let me just copy this. And I'm going to come here and put it. And let me just keep going. So he's complaining about this same array because I didn't create it yet. So I have to go and create it. I'm going to have a method that will return true or false, depending on if both arrays are the same. So let me copy the name of the array. And I'm going to go all the way to the top in this area here. We're going to go public, static, Boolean, because I'm checking something, it's supposed to return true and false. Same array. Now, the parameters, this is very, very important. What am I passing? I'm passing array 1 and I'm passing array 2. So I'm going to come here. What are they? They're integers. So we're going to come here, integer, that space, A1, integer, curly braces, A2. I'm just going to go here, return false, just in case. So this is going to be fixed. I'm going to fix this, of course, in a second. Look at this. I'm passing ARR1 and I'm passing ARR2. And here, when you defined A1 and A2 to receive the arrays, you have to put the square brackets. So this is something you have to pay attention to. Now, the idea here is very simple. Number one, for you to be able to compare two arrays, you need to make sure that they have the same size. So we're going to come here and say if A1.length doesn't equal A2.length. Immediately return false, and there's no need for you to continue. Okay, so this is the first test. I have to check if they both share the same length. If they share the same length, I'm going to go integer size, and I'm going to use one of them since they have the same. So one of them will be enough. And in this case, what I'm going to do, I'm going to copy this piece of code here. I'm going to put it here. Now, again, for instead of 5, we'll go with size. And I'm going to take this and this away, and I'm going to say equal. And I'm going to say here, if, look at this, very, very important. If an item in A doesn't equal the corresponding value in the other array, immediately return false. Otherwise, return true here at this point. So what did I just did here? Let's just go ahead and have a recap on what I just did. I'm trying to check if I have two arrays in two separated spaces in the memory that share the exact same values. So I'm passing those arrays here. First test I did here, I checked if both of them having the same number of values. The length of both of them is the same. So if it's not, return false. After that, I got a for loop. In this for loop, I'm going to go element by element in each one of those arrays. And I'm going to compare it with the corresponding. So the first element of A2 with the first element of A2, the second element of A2 with the second element of A1, 2, and so on. The moment you get two elements that are not the same, cut the whole process and return false. If I passed the first test, they had the same length, and I did all the testing for all the variables, and they're always the same. I'd never get the case where the value from the first array doesn't equal the corresponding value from the second array. And if I pass this test without any problems, then simply return true. Now you will notice that when I did this for loop, this is going to return false, but this one's supposed to return true. So let's go ahead and run that. Oh, why is that? Let's see. It should return true, but it's returning false. Okay, this is where we have to do a debug. So let me just go ahead and put a debug beginning and close here. And let's click on my favorite button and see why is it acting that way. And let's run it. I think it's here at this point. So let's step forward. So we got this. This is going to be false. Okay, this is where I'm going to go step in. I'm going to be moving. So let me extend the view here for array 1 and array 2. You can see they have the same exact value. Now, if I step into, I'm going to be moving here. Now look here, we got A1 and we got A2. And those are the values. So the first test here, if length A1 and length A2 are not the same, it's going to skip that. Now we're going to go to size. What is the value of size? It's 6. We got 6 items. Okay, that makes sense. Did I use 5 here? Did I use 5 here? Yes, I did. So that's where I made a mistake. This is supposed to be 6 because I got 6 items. Okay, now I fixed it. There's no need for me to continue. That made a lot of sense. So let me go back here. Let me run it again. And you can see now it's true. This one was a mistake. Again, since I have 6 values, then I have to put 6 values here. And now this comparison is totally different than this comparison. And because it relies on how did you perform the assignment operator? Did you go item by item, or you did decide to go assign the array by array? This is reference. This is deep. This is shallow copy. This is a deep copy. So if you use a double equal, you're simply comparing it as shallow copies. If you use a function or a method that goes item by item, you're doing a deep comparison. I'm going to stop at this point. And of course, just like how I was able to compare arrays, I can check if 2 arrays are not the same by simply calling the same function and just put not. For example, I come here and put not. That simply means I'm checking if both of them are not the same. For example, after I did this operation, I could come here and change the value for an item, and you can check if they're the same or not the same. Anyway, the last thing I want to talk about here is that arrays could be returned by methods. What is that supposed to mean? Let's go back to those arrays that I created. Let's say the first one, which again is going to equal the same one because I performed this operation. What if I want to multiply each one of those values by 10? Here's what I can do. I could come here, create a for loop, just like I did here. And I could come here and say array of 2 multiplied equal 10. And that simply will multiply each one of those values by 10. So let me just go ahead and create another for loop to show them, so you'll understand what I'm saying here. And we're talking about system print line. This will be the last part I'm going to be talking about. And next class, hopefully on Thursday, we're just going to come to the class and we're going to work on the assignments in the labs if I'm not done. I don't think I'll be done 100% today, but that's okay. Let me just run it. So you'll see that I got 10, 20, 30, or 50, or 60 all the way to the bottom. Now, the question is, what if I want a method to do the job for me? So I'm going to come here and say public static integer, and I'll say multiply by 10. And here I'm going to pass an integer array. We'll call it A. And here I will say A. I have to have a for loop just like I did before. Let me just copy this. So this is going to be A instead of A1, and this is going to be size that's acceptable. And all I'm going to come here and say A of I multiply equal 10. So I'm multiplying by 10. And then after that, return A. Okay. So when you pass an array to an as an argument, you put the square bracket. When you want to return an array, you have to put it this way. Now, instead of me doing this here again, where is it this part? I'm just going to come here and say A2 or not A2. Let me just call the function itself. Where is it? Multiply by 10. So I'm going to say A2 equal multiply by 10, and I'm going to pass A2 as well. Now he doesn't like it for some reason because there's no A2. It's called AAR2. Sorry, my bad. Okay, so let's see if I run it. I'm supposed to get the same exact results, and here they are. Okay, so I'm going to stop at this point, and let me just see here. Next class, I'm going to start with searching in array. We have an array of objects, array of strings, length of array, variable length. We talked about all of those. Just want to know if there's anything left here to worry about. Oh yeah, the last part, we're going to just have one last example about searching for an array. And then we have a special loops called for each in Java, and we get 2 dimensions. So next class, we're going to continue with arrays for, let's say, 30 minutes, and then we'll move on to the questions in the labs. Okay, so I am done for today. Let's just go and stop sharing. Stop sharing. Let me stop